How LaMDA works in January of 2022, months before showing it off at I/O, Google published a more detailed explanation for how LaMDA and its language model work, describing the progress and development made so far on its AI blog. Some of my favorite weekend reading material. LaMDA was specifically created to meet a series of metrics by human raters that prior chatbots had trouble with. Things like the internal consistency, i.e., memory of its responses and how unexpected its answers are corresponded to an SSI sensibility, specificity, and interestingness score. Rather than just meeting expectations, can it make a joke or provide real insight? And how factual and informative are its answers? Using these as measures of success, in essence, targeting the creation of a chatbot that can seem human. Google trained LaMDA's models on a massive dataset, essentially just trying to get it to predict the next components of a sentence. At its core, LaMDA is an ad-lib generator meant to fill in the blanks with details humans will like. The model is then fine-tuned for other applications to extend its generative capabilities to create response candidates for longer responses, further trained using a dialogue dataset of back-and-forth conversation between two authors. In short, it goes from fill in the blank to fill in the sentence, trained to mimic real conversations. LaMDA generates multiple candidates in response to input, picking the best one according to a range of scores. Like many of ML-based systems, rather than generate a single response, LaMDA creates multiple candidates and picks what different internal ranking systems choose as the best one, so when it's asked a question, it doesn't think along a single path to one answer, it creates several of them, with another model choosing which scores highest on that SSI score we mentioned, actively trying to pick out the most interesting, insightful, and curious answer. SSI itself is a human-judged metric, but in its prior MENA experiments, Google demonstrated how other human-judged metrics can be simulated with reasonable accuracy by yet another model, and according to the researchers' paper on LaMDA, direct PDF warning, that's what's happening here, too. This SSI judging model is created with human-generated responses to random sample of evaluation data sets. Basically, a bunch of people looked at question-answer pairs and determined whether they were good quality or not, and a model was trained off of that, augmented with similar training in other categories like safety and helpfulness. If you remember the Pluto conversation demonstration, LaMDA is also trained to consider role consistency, how closely its answers hew to what the target role would have said. Training models on crowdsourced datasets without some fine-tuning is a bad idea. Without this additional training, LaMDA had a tendency to offer, let's say, problematic answers to certain lines of questioning, with room still left for improvement. On top of that, Google's working on ways to make LaMDA even more factually grounded by essentially including citations to external sources for facts in the conversation data sets it trains from. The company is also working to give it the ability to retrieve external information, i.e., fact-check during response generation. Google says it's seeing promising results, but this is very early work. Ultimately, LaMDA's responses can beat average human responses on its interestingness metric in Google's testing and come very close in sensibleness, specificity, and safety metrics, though it still falls short in other areas. And LaMDA isn't even the end here. As touched on before, Google's shiny new PaLM system has capabilities LaMDA can't approach, like the ability to prove its work, write code, solve text-based math problems, and even explain jokes, with a parameter brain that's almost 4 times as big. On top of that, PaLM acquired the ability to translate and answer questions without being trained specifically for the task. The model is so big and sophisticated, the presence of related information in the training dataset was enough.
Thank you for watching. Please like, share, subscribe to the YouTube channel. We will be uploading videos on a daily basis. You can also leave a comment in the comments section on your opinion on the subject.